Hello and greetings to the respected jury, audience, guests watching this presentation on the paper topic Twitter Data Analysis to Enhance Android Malware Detection with paper ID 135. I cordially welcome everyone to the presentation of our paper. I am Abhishek Singh and I am here to present our paper on behalf of our author team. Our core author team consists of A. Vishal Chandra, Alluri Harshit Verma, Vamsidhar Reddy, N. Sai Ganesh and Divya Udayan. Introduction to the topic. Several malicious applications are found in Play Store, but most of those applications are introduced to us via social media. For example, applications like Twitter, Instagram, Facebook, etc. Thus, malware detection can be enhanced by trying to filter out the malicious URLs which are tweeted by spam users, allowing us to find the zero-day malware. In this project, we will be discussing of how people are at risk during the daily session of Twitter. I will be now briefly explaining our system architecture for the project. So, as our goal is to identify tweets which are spreading malware links, we use TweetPy to collect and filter out data that might be associated with malware applications. To prevent any sort of disconnection, while the tweet data is being streamed, we make use of Kafka as a message queue. This involves the producer taking the data and then sending it to the tweet topic. The consumer then receives the tweet data from the tweet topic and adds it to the tweets collection in MongoDB. Now that the data has been collected and stored, we can perform various tasks on it. Firstly, we will filter out the tweets containing the Android app URLs. Then we will identify the malicious URLs collected from the tweets with the help of the Androzoo dataset, which is an extensive collection of Android app APKs and corresponding metadata, which helps in identifying whether it's malware or not. And now, once we have identified possible malicious applications that are circulating on Twitter, we verify if any of these apps are available on Google Play Store. Now, this will help us to identify possible malicious applications that are harming people as they are getting scammed. Furthermore, we extract useful features from the tweets stored in MongoDB through feature engineering and then feature extraction, and we will use this to identify whether the user is a bot or not. So this will help us in further establishing the relation between the bot accounts and the malware spam, as it is like very highly likely that the bots are the ones circulating and spamming the malware. As you can see in this architecture, first with the diagrammatic representation of the Twitter logo, we show that scraping data from Twitter using TweetPy, and then we're sending it to Kafka, then to MongoDB. After that, we are using feature extraction to extract everything, and then predicting whether the user is bot or not using SparkML. And then on the other hand, there's Google Play Store base URL running, which will be scraping Google Play Store to get the URLs of the apps with the help of the crawler program, and then storing the scrapped URLs in MongoDB database. As I've mentioned earlier, for data collection, TweetPy was used to collect and filter tweets which might have anything to do with the malware and Play Store applications. As the amount of data is immense, we made use of Kafka as a message queue so that the stream of data would not disconnect. Now coming to malware detection elaborately, a dataset from Androzoo was then loaded into MongoDB to allow us to filter Android applications which have been affected as malware by other antivirus. This dataset is then compared with the URLs which have been extracted by us from the tweets to obtain the malicious tweets. Now coming to the very important part of scraping Google Play Store. So basically, to get the links of the applications, we had to scrape Google Play Store. Now, in order to scrape Google Play Store, we had used a crawler application or program called Scrapey or Scrapey. So this crawler, begins scraping from the very basic, like from the Google Play Store apps, and then it will traverse to continuous applications, whatever have been filtered out. So you can see the hyperlink here, https play.google.com/store/apps. So that is how the crawler starts scraping from the base, and then it will recursively follow app links which are found in each web page visited. And after that, we had created a pipeline which stores app links in MongoDB, and during the course of this project we have scraped over more than 55,000 apps. As you can see in this short video, Here the scrapey script is being run and it extracts app links from Play Store taken and then stores in the MongoDB database. So here we'll be basically running the scrapey script, and after it runs it will extract all the app links from the Play Store, whatever apps we have taken, and then that will be stored directly in the MongoDB database, which is also running here side by side. Now to process data, we have used MongoDB and like the database. So the URLs obtained by scraping is then converted to a package name of the application. For example, as you can see here, slash store slash app slash details id equals to com.android.chrome is converted to chrome.android.com. So this is like the conversion from the package name of the application of the URL which we have obtained. So here are a set of examples here. For example, there's an object ID given with the URL, and for example here this application is called Pesa user. So the link here is then converted to user.pesa.nbu.apps. To the second example, for example, you are using the Snapseed application. So the object ID is delivered to it, and then the URL is also decoded. After that, it is directly linked to its APK snapseed.nicksoftware.com. So in this way, all the applications which have been scraped are being used to process the data, and all this data is directly being stored in MongoDB. And the extension we're using is called PyMongo. And after this, we'll be iterating over the whole database, and each document will be updated with a new field link with appropriate value. That is what the ID number is. So each URL or link, which is called a document here for our reference, will be processed and given a different number, so that it does not collide or clash with other application links. And here in this slide you can see MongoDB processing. So this is just a small example of what and how MongoDB it was run on our systems. So this is a basic code which was used for the MongoDB processing part by our team. Now coming to another major part of this paper, it was about Twitter bot detection. So basically, machine learning Spark ML techniques were used to predict whether an account is on Twitter, it's bot or a real user. Then after that, we will start reading, cleaning, and then training a model on the taken data. Then the relevant features were found and then used on them for detecting the Twitter bots. Finally, different models like logistic regression and random forest models were used to predict with F1 score as the evaluation metric for the bots. Now we can also get bot predictions of the Twitter data stored in the database, and the database which we have used is MongoDB. In Twitter data analysis, some typical characteristics of bots on Twitter include: many Twitter bots have a relatively recent creation date. Many bot usernames contain numbers which can indicate automatic name generation. High followers and no or less number of friends also is another factor. And then the account's tweet frequency is higher than a human user could feasibly ever achieve. So these were some of the points which we have found out after a lot of research, like to how to differentiate that if something if a user is a bot or a normal human user. Now here is a glimpse of the correlation matrix which was observed after running our model. So there is no correlation between ID, statuses count, default profile, default image profile, and target variable. And also after we observe this heat map, there is strong correlation between verified list count, friends count, followers count, and target variable. We can not perform correlation for categorical attributes, so we'll take screen name and the name, description, status into feature engineering, while we will use this thing called verified and list count for feature extraction. So my dear peers, this is it in a brief note about our paper and its presentation. We hope it's clearly understood by the audience watching this. This experience of being an author in this conference has been really good, and we as a team wish to have attended it offline, but then due to restraints, we understand the protocol and then thank the ICMISC team to conduct the session smoothly online. I would like to take this opportunity and thank the conference and the jury members on behalf of my whole team. Thank you very much.